Now this distance is A. So let me take this is Y. So here is what? The point P3, I'll write it. Now due to the positive charge, how the field should be? Let me take help of arrows. So due to positive charge, the field should be in this direction. And due to negative charge, let me take this is a negative, this is a positive, no? Yeah, come for this one. And due to positive charge, how the field should be directed like this. And due to negative charge, the field should be directed first. Let me give the color, and then I'll bring the arrows. Okay, fine. So what is this? This should be E plus. This should be E minus. Okay, let me take this is theta. This will be theta. And so this distance will be R. Now what is the value of E plus and E minus? Should be equal to KQ by R square. Okay, let it be this much here. So what is the resultant field at point P3? The resultant field should be towards left due to E plus and E minus are equal, and they and they make equal angle with the horizontal. So therefore the resultant field is given by EP3 equal to E plus cos theta E minus cos theta, and the magnitudes are equal. So therefore 2 E plus cos theta. 2. What is E plus? E KQ R square. What is cos theta? Cos theta will be, shall we go for A by Y? Sorry, A by R. So this will become 2K QA R cube. Let me adjust 2A Q K R cube. So what is 2AQ? 2AQ will become dipole moment. No? Very important. Everywhere, try to think about the dipole moment. What is the electric dipole moment? Not like always, the orientation. Say for calculation purpose, I'm just putting the dipole moment. The dipole moment is a vector, no? Let the dipole moment will be along x-axis. Say vector should be always along positive axis. Nothing, no? Vector can have orientation anyway. For our calculation purpose, I'm just assuming dipole moment is along x-axis. Fine. It's not a necessary condition. It's a vector. When I say vector means or, no? Okay, no. Let's get into the mathematics. So what is R? Further, this will be EP3 equal to, this will become PK. R cube will become Y square plus A square to the power of 3 by 2. Further, P, this will be 4 pi epsilon naught Y square A square to the power of 3 by 2. Again, A will be very much less than Y. So therefore, what is EP3? EP3 should be equal to P by 4 pi epsilon naught Y cube. What is the direction? On the bisector, how the field strength will be? It will be directed opposite to dipole moment. On the bisector, there's a bisector, no? Green color line, this one. On the bisector, how the field strength will be directed? The field strength will be directed, the electric field will be directed opposite to the dipole moment. Suppose if we have a dipole here, I think I'll give very generalized diagram. Please do remember. This is a bisector. At all points, how the net electric field strength will be directed. The P bar will be like this. At all points, how it should be directed. And we know as the magnitude Now, what are these length of arrows? It will indicate the magnitude, no? Everywhere on the bisector, the E bar will be directed opposite to P bar. And as we move away, what will happen to the magnitude of electric field will keep on decrease. And everywhere on the axis, how the E bar will be directed towards right. I'll present the total description. So I think this diagram is going to help you a lot. Let me show this. E bar vector here and E bar vector here. Point P1, point P2, P3, P4. Okay, now I think make memory of this diagram. This is very important. Make memory of this diagram. Now look at this one. On the axis of dipole, how the electric dipole moment will be? In the direction of, on the axis, the dipole moment will be, electric dipole moment will be directed along the axis. On the bisector, it will be opposite to, it will be directed opposite to the dipole moment. And what about the field strength? Usually we'll discuss for short dipole. What do you mean by short dipole? The distance between the charges will be very small compared to the distance where you are finding out. This condition is very important. Look at this. Almost every problem, what all we discuss problem, this condition is by default also you can take it. You need not to mention. Even in exam, they didn't mention A very much less than Y. It is understood. It's taken for granted. It's a by default. Because what is the molecular range? Molecular range will be of order 10 to the power of -10, and what all the distances y what we take, no, it's external, no, definitely it'll be of like 100 or 1,000 times. So in a questions in exam, they need not to mention this. Okay, all of you. Okay, no, fine. So now we are in some better position. We are able to predict the field on the axis and on the bisector of a electric dipole. So what is electric dipole? It's nothing but an atom. So now, shall I ask you a question? Can you find out the field strength due to an atom in a material S? You can say on the axis and bisector S. Sir, I know. Thank you very much. In chemistry, I think you need this very much. Some of the reactions, you need this idea. This field is very important. Any doubts? You can just clarify it. I'll go for the next condition. Any doubts are there?
Sir, is the dipole like on the axis, as we move away from the dipole, the electric field decreases? No?
As you move away, electric field strength decreases.
Okay.
As you move away, the field strength decreases. Here also the field strength decreases. Because as y increases, the field strength should decrease, no?
Yes, sir. Thank you, sir.
So this, let me write E bar, so that will be easy for you. What is that arrow? Arrow is again not a dipole. Huh? P1, P2 are points. They're not dipoles. P is a electric dipole moment. Okay, now I have some doubt. I want field here. What shall I do? Let me trouble you people with this question. So I have a dipole. So I want the field strength somewhere here, where this will make an angle theta. Let me call that as point A. Dipole moment, let it be P. Now, how you are going to manage here now? Anybody? Can you put any effort? So what is the condition? The field strength at a distance r. What is r? R is a position vector. R bar is a position vector. I want the field strength at this point. So what is the method? I think definitely we have to put some effort. No. What is the effort? Like first, you should calculate the field strength due to this positive charge. Then next, again, the field strength due to the negative charge. So the negative charge. What you should do now, you should take the resultant of these two fields. This is E minus E plus. I think the lot of maths is there. Am I right? The maths is not that easy. This is R1 bar, this is R2 bar. So solving it is a very, very lengthy method. It's there in the NCERT book. If you're interested, you can go through it, but not needed. Let me come with some alternative method, a very easy one, and it will be very helpful for you in the exams also. You can easily remember. So what is my question? Not only on the axis on the bisector, anywhere surrounding the dipole, can we find out the field strength? Earlier, what we did on the axis, on the bisector, somewhere here, what is the field strength? Somewhere here, what is the field strength? Somewhere here, field strength. Anywhere, at any arbitrary point surrounding dipole, I should be in a position to determine the the field strength and also the potential also. So what has to be done? Okay, for that, now first let me go for after getting field. What about the potential? I think potential will be much easier, no? Potential on the axis. So that should be equal to KQ by X minus A, KQ by X plus A. So this will be KQ X plus A minus X plus A by X square minus A square. So this will become KQ 2A X square minus A square. So 2AQ, what you can write it as? The dipole moment. So therefore this will become KP X square minus A square, or this will become P by 4 pi epsilon naught X square. I think this will be more dangerous for you to remember. Usually we have come across so many situations where potential was proportional to X, no? Proportional to 1 by X, it was inversely proportional to 1 by X. Or the potential was proportional to 1 by X. But here what when potential on the axis of dipole is proportional to 1 by X square. And anyway, this is a scalar quantity. I need not to show direction. Only magnitude is what you have to substitute. What about potential on the bisector? I want potential at this point. Will it be positive or negative potential? Anybody here? Can you reply? On the axis, what will be the electric potential due to dipole?
Positive.
Will be positive. What about here?
Negative.
Will be negative. Huh? Because this point will be near to the negative charge, no? So everywhere here potential will be negative, here it will be positive. What about on the bisector? On the bisector.